Hi everybody. Hope everyone had a great spring break. What we're going to do this week is just review chapter 11 and just look at some examples. We're going to have a test on Friday. The test is basically going to be the same stuff as the quiz. So make sure you watch all the videos we put on this YouTube page to make sure you guys are fully prepared for that test coming up. All right. So let's look at the basics of 11.2 right now. So remember, in 11.2, we dealt with prisms and cylinders. Now remember, the volumes were the same basic formula. It was just volume of a cylinder is the same thing as the volume of a prism. However, the bases are just what's different. And the height length is that same height length. So the base here would be the area, that base would just be pi r squared, and we saw that as a circle. And the area of this base, this is just going to be a square or rectangle, which is length times width. Okay, so all we do is the area of the base times the height for a cylinder or a prism. And now remember, there's more types of prisms that we have. We could have prisms that are also triangles on the bottom. Let me just erase that, make that a little better. We could have triangular prisms. Which look like that. So this is the same thing. The volume is base times height, capital B times height. In case the area of that base is going to be base times height divided by 2, which is the triangle's area. Okay. So then we looked at 11.3, which had to do with cones and pyramids. So we had some cones and some different types of pyramids. Here's a rectangular base pyramid. So number 2 is a rectangular base pyramid. Number 1 is just a cone here. So the formula is the same for both of them, but this is 1/3 capital B times H. So the only difference between this formula and the last formula from 11.2 is we have 1/3 in the mix. Okay, so the base is still the same, so that's still the base, this is still the base. So the cone base is a circle, so that base is pi r squared. And this base here happened to be the triangle, which is base times height divided by 2. So what we would do for these two formulas is just do whatever the area of that base is times the height, and the height goes from the base to the tip on both the structures. So that's the height, kind of the same thing as the cylinder and the prism. And the last thing we talked about was spheres and hemispheres, or domes. So with spheres, we were given the radius, and with hemispheres, we could be given the radius or solve for the radius, depending on if the volume was given to us. And we're going to look at a problem today. We solve for the radius given the volume of the hemisphere. So the formula for the volume of the sphere is just V equals 4/3 pi r cubed. And it's easy to remember that it's cubed because it's 3D. So think 3D and cubed. And this formula, which we have all these formulas in our theorem books, is 2/3 pi r cubed. All right, so it's 2/3 because we just divide the volume of the sphere divided by 2. Okay, let's just write down some basic base formulas here. Let's say we have some prisms now, and let's say this prism has a trapezoid as a base. So let's just look at this base. So remember, the prism volume is just capital B times h. So we will be given this height h, and we would just need to have this base to find the volume. So the base here is 1/2 little b plus big B times h. So in this formula, we kind of have two different types of h's here. This is the height of the purple one is the height of the trapezoid on the base. This little b here is the little base, which is that section, and the long side is capital B. So this is the formula here that we would use for that base. So I'll color that purple here. And of course the height would be given to us here to find that volume. So that is the trapezoid. What I want to look at now is some common problems that we had issues with on the quiz, the last quiz we took, so we can make sure we get those right. So let's look at this one now. The question was, what is the radius of a hemisphere with volume equals 144,000 pi cubic centimeters. Pi centimeters cubed. Okay, so let's write down the volume of that hemisphere, which we should have in our notes. Make sure you use that. So the volume of a hemisphere is V equals 2/3 pi r cubed. And we're solving for r here. So we're given the volume, in this case it's in terms of pi, so 144,000 pi, that's our volume, and really we have everything else we need, because pi is 3.14. Okay, let's erase that to make that look a little neater here. 3.14. And r is unknown, so we'll keep that r cubed. Alright, so let's just write the decimal form of 144,000 pi right now. So that's going to be 452 160 equals 2/3 of 3.14 times r cubed. Let's figure out what 2/3 of 3.14 is. Okay, so let's just round that to a decimal point here of the hundreds place. So we'll call that 2.09 r cubed. Okay, so that's here where we are right now. On the next slide, what we want to do is divide both sides by 2.09. So we're going to write the left side, which is 2.09 r cubed. So we're going to divide both sides by that to get r squared by itself. Okay, so let's see what that is. 2, okay, so 452,160 divided by 2.09. Okay, so that's going to be 1, 6. And we're going to round to the hundreds places again. So we're going to have 0.50 because that was 0.497. We're round to the hundreds place. Now what we got to do is take the cubic root of both sides. Alright, so let's take that cubic root here. Let me pull up my calculator and see what we get when we do that. Alright, so we're going to do the cubic root of 216,344.50, and we're going to calculate that. Okay, so here what we're going to get is 60.03. R equals 60.03. So on the quiz, I think it asked us to round to the nearest whole number here. So the nearest whole number would be 60. And this, did it say the units here? Yeah, centimeters. Okay, so that would be 60